Welcome to the new Cyber Frontier, bringing you the latest news on the local Colorado economy and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host, Chris Gorog, brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. Chris is personable and opens up with our guests on issues we all would like to see addressed. You can find us on the web at www.newcyberfrontier.com.
Welcome to today's episode of New Cyber Frontier. Before we introduce our great guest for today, I wanted to make you aware of an upcoming event that you'll want to add to your calendar. We hear so much about unfilled positions and talent shortages in the cybersecurity industry. Our sponsor, Jacobs Engineering, is having a hiring event on November 21st, 2019, to showcase a long list of open positions in some of the top cyber agencies. If you're new to the industry or just interested in maybe making a transition and seeing what's out there, you don't want to miss this event. November 21st, 2019. For more details, look at our site, newcyberfrontier.com. Now let's join the conversation with our great guest for today.
Welcome, Shawn. Thank you. I appreciate it. Yes, I've been on boards for a number of years in system engineering and cyber here. Career goes back 39 years. So.
Why don't you tell us a little bit about your background? Where did you cut your teeth? Where did you come from before you did cyber?
Actually, my background is system engineering, and I was doing it before I knew what it was called. And got into cyber as a one-time good deal, and that was over 18 years ago.
Yeah, they weren't calling it cyber then, were they?
It was called information assurance, and it was basically in its infancy. 16-tab format, DITSCAP, DIACAP, now to RMF. So over the years, the granularity of the requirements has grown, and the end products, by and large, have gotten better, but it takes more time. As you know, on the number of controls and stuff like this, into the thousands, it takes manpower. There's a lot of tools and stuff to help, but you still have to put eyes on to make sure that the data is the correct data. So started out in the oil fields of Wyoming as a field engineer, working on a bunch of analog well monitoring equipment as they were drilling oil wells. And got tired of traveling. It was gone. Every week someplace I was going.
Sure.
On the road. And went back to school. Got a bachelor's degree in electronics, and started my high-tech career here locally. And that was back in the early 80s. And that was in high-volume manufacturing of floppy drives and disk drives, and worked my way into defense contracting, and have been there ever since. So I've worked for Boeing, for GPS ground segment for 10 years, doing the cyber work there. I've also been principal cyber engineer on missile defense, working for you, actually.
long time ago.
Yes, it was. And remained in the local community and following the contracts. And cyber has a great demand locally here. A lot of it is driven by certifications and clearances, which unfortunately is kind of a barrier to some new people coming in if they're not coming from active duty with a clearance.
Sure.
Which is a topic that you and I, commiserate about, on First Fridays meetings and other events. How do I get in? So the chapter, ISSA, is working with that and with the Economic Development Council locally here. And
Senator Bennett's office, we're collaborating with him now that in his new position.
Yes.
Yeah.
So everybody's seeing a problem, and they're trying to find a solution to free up some of these people that are qualified but can't get into the DoD because of the clearance issue.
We'll be with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
Currently, and hopefully, the government will see that there's value in trying to fix this. And they've moved out, the re-ups a year, on the secret, and the
Sure.
is for that reason, that there's such a backlog. So hopefully they'll find a solution.
Well, there's a discussion now in continuous monitoring for clearances where, instead of going through a periodic investigation, you actually, if there's no real changes in what you're doing, your lifestyle, your relationships, no foreign travel, to actually go into a continuous monitoring phase. But those that are more sensitive or critical, still going through that periodic. So, you bring forth an interesting perspective when it comes to the clearance issue. Let's focus back on the engineering perspective. There's so many different disciplines to cybersecurity. We have software and we have accreditation. You kind of hit up on that a little bit. But when we talk about the risks associated with technology in our information systems, in our networks, you go back all the way to talking about oil fields out in Wyoming. When we start automating our processes and whatever that business is, whether it's oil or a missile, being developed by Boeing or Lockheed or Northrop or somebody else, what are the cybersecurity perspectives from an engineering perspective? Why is engineering really important today? I mean, we talked about the evolution of where you came from. You've been doing this for a long time. But from a hardcore engineering perspective, why is that really important, Scott?
Part of the problem that we have today is, I'll say, self-made. Years ago, most of the networks that are being used in DoD and elsewhere were essentially verticals and semi-isolated. Nowadays, we're in an interconnected world. And a lot of the infrastructure that these networks were built on were not really designed, and security really wasn't thought of part of the baseline. So now we're taking this stuff and hooking it together because we can, but I think there should be a step back and look at it and say, should we? And you inherit the illities, the deficiencies of your neighbors and whoever you're hooking to and expanding this network. It's basically information anytime, anywhere, but along with that, is inherent deficiencies, configuration issues, being able to have a confidence level that overall you're in a secure posture.
So it's not just functional that we're looking at, which has always been the mentality, right? How efficient is the product? Is it meeting the end user's expectations? But because we have bad people, now we have to look that it's secure.
True. And I mean, the bad guy only has to be right once. The infrastructure owners have to be right 100% of the time, and that's not possible. So that's why they're starting to look at doing, VPNs, virtual private networks and this type of stuff to get these networks out of a flat configuration and more into a modular configuration to make it harder for the bad guys to get in and make more hurdles or trip points so that you have a higher probability of finding them sooner than later. And that's a task to put something like that into an existing infrastructure. If you're starting from scratch, lessons learned, you'd have a better opportunity to build a robust network. And a lot of, we'll go back to government, their networks are so large, and it takes so much time and money to upgrade stuff. And in companies in general, the time frame to do stuff is prohibitive, if you will, to stay on the cutting edge of technology, to do the monitoring, the continuous monitoring, the auditing, the patching and updating, to where you have a better confidence level that you're keeping the data secure, your customers' data secure, and it's kind of like bolting it on cyber after the fact, and it's going to be that way for an extended period of time until these networks get replaced, if you will, with better hardware, better firewalls, that type of stuff that will keep the entry points, if you will, more robust. And then you can work on the backside on the core infrastructure, because you're starting to work on defense in depth to where you can isolate certain pieces. All data is not equal in value, and sometimes the mentality is that we'll just protect all information at the same level, and a lot of times you're over protecting lesser data that may have a very short shelf life that gets replaced on a regular basis, and by doing that you inherently inject more cost in time and manpower to maintain something that you really should be focusing on more of the core. What data do you absolutely positively need to hang on to and protect to the best of your abilities? Part of the reason for this is if companies are acquiring insurance, cyber insurance, catastrophic in the event of, the insurance companies are getting more educated as to how to write a policy. A few weeks ago at one of ISSA's many seminars, we had a gal in who was an insurance agent, and that's one of the areas that they specialize is in cyber insurance. They employ investigators that actually go out and will do an assessment on the company to see if they're doing their patches, their updates, they're doing audits, backup data, and this type of stuff, to see that they are doing due diligence and at least making the minimum water level to make them insurable. In the early days when they were doing, insurance companies were providing policies, if something happened, they paid. Now they're getting smarter that, there's got to be skin in the game on both sides. And that's, I think, putting a different wrinkle to companies, that they have to really be invested. Just don't talk it. You have to actually be producing and showing that you are, and not a one-time deal, but it's continuous.
It's interesting that you say that about the insurance companies. When I remember hearing from a cyber insurance underwriter, when the industry first came out, they were looking at it and saying, cybersecurity insurance? That's just free money. Yeah, we'll give you a policy for whatever you want. They did, like you said, though, they didn't have an understanding. Mm-hmm. And so it's interesting to see now, after all the payouts, especially when you think of a breach of 1 million people. If I've got to notify 1 million people, price of a stamp today is 50 cents. That's $500,000 just for the stamp. Mm-hmm. Let's say the notification, the paper and the envelope is another 50 cents. There's $1 million, right? Just for the notification. That's not counting, the credit monitoring or anything else or any of the lawsuits. That's just for the notification piece. interesting conversation. We're going to take a break. We're talking to Scott Frisch, a senior cybersecurity engineer with Odyssey Systems Consulting, also executive board member, vice president for the Colorado Springs chapter of the ISSA. We're going to take a break with our sponsor, and we'll be right back. Murray Security Services are your cybersecurity experts with decades of experience providing professional training services for our clients in various industries. We offer professional training and certification in areas of cybersecurity, safety, health, and environmental services at our academy. Our in-person and online training provides a collaborative environment where students can interact directly with instructors through live chats or in private classrooms. Visit murraysecurityservices.com for more information. Welcome back. I am Shawn Murray, the host of today's edition of the New Cyber Frontier. Today's edition, we welcome Scott Frisch. We've been discussing, cyber security engineering and some of the other implications and how other stakeholders, other organizations are getting smarter. Specifically, insurance companies. You mentioned the due diligence, right? So, due care is what we owe our customers. Due diligence is the actual demonstration that we're doing due care, right? Yes. And now cybersecurity insurance underwriters are saying, hey, you have to do due diligence. Your due care is to patch your network and have a security architecture and documented security policies. And if you don't, as part of the due diligence, when we come and investigate, when you do make a claim, we're not going to pay out if you're not doing these things, right?
Correctly.
So part of that should be engineering cybersecurity into your business processes. When we take a look at providing new systems or providing interconnections between systems, so a manufacturing network with a business network, there may be a business case for why that's important. But if I can send a phishing email and compromise your business network to get over to the production network, that's basic systems engineering.
Absolutely.
Why is that important?
A couple of years ago, Dr. Ron Ross from
NIST.
He was out here for ISSA's fall conference, and I got a couple minutes with him after he was done, and I asked him the question. It appears that system engineering and system security engineering are morphing together. And, Dr. Ron Ross, he's very quiet, and he kind of chuckled, and he said, they are. He says, if you do good system engineering, you're doing good system security engineering. If you're doing good system security engineering, you're doing good system engineering. And that's kind of the philosophy it should be. Cyber needs to be baked in, and folks that I've dealt with over the years, developers and integrators and stuff like this, I've always asked them, when you start thinking about a project, please holler. I want to be involved in this because I want you to do due diligence, if you will, on your design, properly vet what problem you're trying to solve, and bake the cyber component into it. That way it morphs in the background, you're not chasing it at the end, and I can help be basically a tour guide, if you will, as some of the things that are going to come up, putting your design together, things that the government, or the eventual owner, operator is going to be looking for. So let's get started early on this and get to the real meat of it. And I've had differing degrees of success at this. Years ago, I had a group of system engineers that were less than enthused with my approach, we had the same manager, so I went to him and I said, I want 4 engineers over the course of a year. I want 1 a quarter to come and work with me and bring their project with me to where we can take it apart and start looking at it and have the conversation back and forth of why. Why do you want this? Why are you asking for hardware, software with us? Why are you asking for configurations? And when it all finished up at the end of the year, I had created 4 advocates that went back to the engineering group that when they started talking about it, said, hey, we need to call Scott. We need to bring him in. This sounds like something that he can help us with, can provide, some points of contacts that we can get deeper into this to where it isn't a problem later on. And part of it is picking the right equipment, picking the right software, getting the customer buy-in. The bottom line on this, Shawn, is communication.
Sure.
Cyber is about communications. It's similar to system engineering in that you have ownership in a lot of different disciplines, within a company, and you're the one that kind of is the glue between all the processes to make sure that the end product is what the customer requested.
That functional piece, right?
Yeah, and it's like I tell people, I would rather have the customer unhappy up front and pleased at the end than happy up front and mad at the end when the time and the money is gone and don't give them the right process. And it gets contentious at times having conversations, but the end result is if people can see the positive at the end, then I think everybody's the better for it. The next cut on the next project, they have better understanding of what the expectations are. And they get more enlightened as to when you come and ask them questions, that now they're more willing to provide answers because they know you're there to help them, not hinder them. Years ago, I had 2 software guys, and they liked the new shiny stuff. And
they always do.
Just in passing conversation with them, they let it slip that they found the new shiny toy and that they were going to integrate it. Well, after a couple questions that they couldn't answer, I went and had a chat with their manager, and needless to say, the shiny new toy didn't get implemented because it hadn't been a requirement. It was so new, it wasn't on the common criteria list.
Hadn't been evaluated at all, huh?
Yeah, and they were going to be the first one in the barrel to try to implement this. And I flat told them, I said, I will go to the government and ask them, but I said, I'm not going to, burn goodwill for something that you may not use.
Sure.
Let's go back to, a preferred list. They're comfortable with that. We can do the delta or incremental, if this is what really needs to happen later. So you get out of this, argument discussion with the customers and developers and stuff like this, and boil it down to what problems are you trying to solve? And part of that goes into root cause analysis. Is it a symptom or is it a root cause? And you got to get it down to the root cause, and that's where part of the engineering piece is, going and doing the analysis. And a lot of times that gets overlooked. We got a problem, we're going to go fix it. Well, are you chasing the right problem? And there are times where it is not the right problem. It's a symptom. But you don't know that until you dig into it far enough to see. And people look at it as time and money. It is. But then you can look your customer in the eye and say, we did due diligence. We did root cause analysis. The symptom is not the problem.
Yeah,
If it's the problem, the symptom will go away.
The problem may not be the system at all. It could be a
Absolutely.
process. It could be a human problem.
Yes.
It could be a communications problem.
Mm-hmm.
And until you do that root cause analysis, you're not really going to have a great understanding. And one of the things that you and I see today, especially when we talk about systems engineering, on the government side for our clients, you got to get that accredited now.
Absolutely.
Right? And so the authorizing officials are now starting to ask those questions. Hey, where's your systems engineer, and how is this configured, and how is this outlaid, and how does it communicate? What is your protocols and services doing, and what are the vulnerabilities associated with the technology? Has all of that been considered? Is that documented in your system security plan? They're asking those questions now, so it's a lot more difficult for engineers that are not stepping up to have the mindset of integrating cyber security at the beginning. Are you experiencing the same things that I'm describing, the same things that I'm seeing?
Absolutely. And part of what I know we've both seen is not fully understanding your environment. What is normal? What's supposed to be there? And we've had conversations with customers. I don't know what that is. Well, you need to understand what's in your environment so that you're properly addressing it. If it's not supposed to be there, get it out of there. There may be a perfectly logical reason it's
or a
there,
business case,
but
right?
it needs to be properly documented and not one deep someplace. And to me, if you don't understand your environment, it's very hard to defend it. You can put in HBSS, you can do the monitoring stuff, but you have to do baseline configurations. You have to know what's supposed to be there. If you're getting spikes at 2 o'clock in the morning and nobody's there, that's an indication that you maybe need to go take a look. Even though everybody's driving towards automation to address the manpower issue and deficiencies a lot of projects and programs have, the bottom line is you still need eyes on the results. Systems will give you data. You need to understand whether it's the right data, and if it isn't an inherent problem. If something new is popping in there and no projects have been done, something changed.
Sure.
You need to go take a look at it. And it may be, it was an upgrade, that it was unforeseen that they were going to add overhead, through the throughput, and now we're starting getting alarms. Well, you need to go back and re-baseline your auditing capabilities and this kind of stuff. So it's not a one and done. It's a continuous evolution, if you will, for cyber, because it's in everything, and it's on a day-to-day basis. It's becoming more. One of the things is the Internet of Things. Bring your own device, to work. That gets into cost reduction for an employer. If you're bringing your own cell phone and laptop and that's to work, the thought is, well, A, I don't have to pay for it as a company. B, the employee understands and is comfortable with their own technology. But the problem comes in the legal side when something happens. Not if, but when, because it always does.
And the risk associated with that, right?
Who owns the problem now? Is the employer going to confiscate the equipment that they didn't pay for? Are they going to sanitize it through their analysis? They find something that had nothing business related to your employee. Now what do you do? Is the company going to compensate the employee for the confiscation of their devices?
Do they have the legal right to confiscate the
that's
devices, right?
You
It
know,
comes down to policy.
Do they have the right to push patches and updates to your devices? Or do they have the right to audit your devices? And part of the problem, that I see with technology is, and functionality is, it's outpacing the policies and procedures and the management companies have for their employees to do this kind of stuff. And the accreditation part, or what you mentioned, takes a long time to do this. Well, the technology that you've picked is already mature, almost to be obsolete, by the time a project actually gets fielded.
It's a significant problem.
And it's a cost, and that's one that they're struggle with, trying to figure out what is smarter. Going to a virtual environment. That gets into monitoring issues. If you are doing virtual private networks, can you scan across all these? Are you punching holes in your environment to do scanning? You're degrading your own environment to do auditing. So that's a lot of things that the engineers and companies, in management really need to sit down and take a look at. Are we integrating projects in a smart way that have value added and that has potential longevity, that we can build upon? And that goes to the core of their networks, the backbone, if you will. And a lot of networks have been just cobbled together, just keep incrementally being built on, and at times I think you need to take a real hard look at, is this still working? Or do we need to go to the next generation of network, with newer technology, faster technology, and that gets into cost and training and maintenance and all the other aspects of we're dealing with today.
Yeah, you've made some great points, focusing on system engineering, policy, collaboration, communication, keeping up with the pace of technology, which that's a future discussion, but it's a really important one because that identifies a gap. This is Shawn Murray, host of today's edition of the New Cyber Frontier. It's been a pleasure to have Scott Frisch, who is a senior cybersecurity engineer with Audacity Systems Consulting, also serves on the local chapter for the Colorado Springs chapter of the Information Systems Security Association as the executive VP. It's been a pleasure having you. Well, any final thoughts, departing thoughts?
Keep up the good fight. We're all behind the power curve, just due to manpower and technology, but if everybody does something, that's better than
nobody doing anything.
Absolutely.
Right? Well, great. Well, thank you, Scott, so much for contributing to our podcast today. You have a great afternoon.
Okay, thank you, Shawn.
We hope you have enjoyed this episode of New Cyber Frontier. Remember, please follow and participate as New Cyber Frontier is supporting a grassroots community effort to empower the individual in the digital age. Check it out at privacyforthepeople.org. Also, make sure to join our mailing list so we can keep you informed. If you have an idea, if you have a question you would like to hear answered, or if you just want to get involved in what we're doing, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors links because they are the ones that really make this show possible. We look forward to seeing you on the next episode of New Cyber Frontier.